All right, if we can hit the light so you can see a little bit better. I've already checked on a couple of folks, but can everybody in the back hear me clearly? Awesome. If at any time you can't, just do something, so that I can see. Can we kill a little bit of the lights? Or can you see that clearly?
In the booth, are we able to dim the lights a little bit? I'll run up it.
Okay. No problem. Can you read the yellow on the blue? No problem. Kind of give me a thumbs up if you can. Great. All right. So not to insult your intelligence or anything, but that's what I'm going to talk about. And that's who I am. And not only is the talk about something that was serendipitous, but I took a serendipitous kind of path to get there, which is kind of meaning circuitous or snake-like. I could have never predicted what I was doing when I did this, when I was in your seat, okay? But it all worked out. So there's some of the students that I worked with. The one disclaimer that I'm going to do is that a lot of the slides that I'm going to be showing are public domain slides of the things that I'm going to be talking about, but they're not slides that I necessarily took. I have a bunch of those, but I've made a recent move to Michigan, and they're somewhere out there hiding in the cloud. That would be the opposite direction. And I've given all of the hard copies so that I couldn't even scan them to the research center that I'm going to be talking about. So I thought I was kind of done with them. Oh, that's kind of nice. I like the dark. Okay, at any rate, let's move on. So the place that I'm going to be talking about is Andros Island, and it is part of the Bahamian archipelago. Whoa. It's called Fat Fingers, I think. Yeah. Okay, let's do off. Can y'all handle that? Okay. All right, now I think we're on the right track. Evidently, they're making a YouTube out of this. Can you imagine how confused they're going to be already? Okay, so, there we are. And so this is the place we're going to be talking about. It's Andros Island. Whoa, whoa. The bad news is that they have the laser pointer right on top of the...
And the laser's the very top.
Thank you. There we are. Okay, so Andros Island is part of the Bahamian archipelago. Archipelago simply means that it's a lot of islands. And you'll notice that it's only about 130 miles or so from Fort Lauderdale, Miami to Andros, okay? We're north of Cuba a little bit. And this is a blow up of what it actually looks like. I'm sorry, it came out a little fuzzy. This is a pretty big magnification. So here's the island. And the cool thing about the island is that in front of it, it has a trench called Toto. It's not Kansas, don't worry about that. But Toto is short for the tongue of the ocean. And it is a canyon that is a cul-de-sac, which means it's a dead end. And it is deeper and steeper than the Grand Canyon. So we go from along this coastal area of 10 to 15 feet depth to well over a mile deep across here. To orient you a little bit more, right in here is the only natural port, and it's in a place called Fresh Creek. The United States has a research station there called AUTEC. Other than that, it has no natural ports, which plays really importantly into the whole talk, because it also means then that there's no tourism for the most part. You don't have, cruise ships coming in and whatever, but it's really close to this island, which is where Nassau is. And everybody and their grandmother that comes to the Bahamas goes to Nassau. But the nice thing is, even though 65% of the land mass of the Bahamas is all on this one island, nobody goes there. And for me, that's awesome. All right, a couple of quick fun facts about where we're going to be looking at. Andros is 140 miles long, about 35 miles wide at its widest point. When this whole story starts, is back in 1980. When I first was going there, there were about 12,000 souls living on Andros. But the funky thing is that now in 2020 plus, there's less than 7,000. So it's one of the few places that actually has a declining population, and there's a real simple explanation for it. There's no jobs. So all of the kids, if you want to call kids anywhere from teenagers on up through 20s and 30s and 40s even, are all leaving Andros to go to places like Nassau, where there's a lot more jobs and opportunities professionally. And also, there's really nothing school-wise once you get above high school. So what that does mean for this island is that there's no commercial fishing. There's really no, organized farming. And that means for the reef, which I'm going to be talking about, is that there's very, very little nitrate or phosphate pollutions from runoffs. And that's really kind of important because both of those things can be detrimental to reef growth. So very little tourism, which means that the reef doesn't get visited very often or very much of it. The reef itself is 140 miles long as well. So it goes all the way from here all the way down to here with a few interruptions in it. Okay, that makes it the third largest barrier reef in the world. For those of you that are just curious, you all have heard of the Great Barrier Reef. That's obviously the largest. The second one is in Belize, and it's argumentably longer, but maybe not because it has more interruptions in it. But that's something for people to argue about and arm wrestle. I've talked about the only natural port. Funky things about this place is I started going and visiting in 80. They didn't have island-wide electricity till 1990. So you can kind of imagine living in that kind of an area. If you needed electricity, they had a couple of big generators in the towns, the two larger towns. But if you needed it kind of off-grid, you had to have your own generator. So when I first started going there, they would run the generator for a couple hours in the morning until everybody left to do what they were doing, and then a couple hours in the evening. But at 9 o'clock when the generators went off, it was pitch black at the research station. They also didn't have any landlines. When they first decided that people needed to communicate, there were a couple of places that you could go to make calls, especially international calls. But they had a little building with an operator in there, and you'd tell her where you want to call, and she'd put it together and then hand you a receiver so you could talk. It's kind of weird. But they made the decision in 2000 that they really weren't going to go and put landlines. It was too expensive to run landlines during the whole thing, especially when cell service was starting to come about. So they did something rather unusual. All of the local Bahamians have satellite cell, which is the kind of stuff that, drug runners and things use. So you get little kids, in elementary school whipping out their cell phone, and it's a lot better than yours. All right? They have cell service now to anywhere, just anywhere in the world. So what they did is they gave them all the phones and then free, and then they just charge them a monthly, service for it. So kind of interesting. There's really only one road to speak of. It's called the Queens Highway, and it's right there along the coastline that I'm going to be talking about. And then there's all the settlements are all on the same side, except for one, and it's pretty hard to get to. All right, so the story that I'm going to tell starts in 1980. I was a graduate student at Wright State University. I did my undergrad at Ball State, and you might go, wow, what's a Marine guy doing at those two places? Well, at the time, I didn't know I was going to be a Marine guy. And I grew up in New Haven, so those of you that are from around the Fort Wayne area know that I was just down the road. My wife and I were hometown honeys. And we've now been together for over 50 years. I know, that's pretty amazing in itself. Anyway, I did my undergrad at Ball State, and I did degrees in geology and natural history, which is now called environmental science. When I was in grad school, my first year, they taught a course, and it was the first time they were ever going to teach this course, down on this weird island in the Bahamas called Andros. And my advisor says, "You want to go?" And I said, "Heck yeah." So the two of us took scuba divings together as part of my course load. Not a bad gig if you can get it, let me tell you. So he went down as a guest instructor with the main instructor, and I went down just as a student. And it was a month-long class in June. And you got to remember, no electricity, no refrigeration, none of that stuff, okay? So it was pretty, I wouldn't say brutal, it was pretty cool actually, but not many amenities. We lived in little cabins, and during that entire month, we were spent studying sedimentary processes that led to sedimentary rocks in geology, because this was a geology course. But they did give us 4 free days. And because we had taken the scuba diving certification, my mentor and I both decided to charter a boat and a dive master to take us out on the reef. He was a paleontologist, as I became, and his interest was in ancient marine animals. So we thought, wow, we're going to go out and see what the real, modern analogs of those things look like. So we went out, and basically we were just tourists. He'd never been scuba diving before either. And we brought along this really horrible, chunky, clunky camera over there, and that's it. It's an Iconis. It probably, when you got the strobes on it, which stick out like even bigger antlers, was probably close to 25 pounds. And it was pretty tough lugging that sucker around through customs and on the plane and all that kind of stuff. But we went out and we took some photographs. And again, remember, these are not my photographs. Ours didn't come out nearly as pretty, but this is what we saw. And it's actually, those pictures are all on the Androsian Reef back from that time, but they just happened to be by professionals. So we were just tourists taking a lot of pictures. We discovered very quickly that our expectations perhaps exceeded some of our grasps. It was expensive. We came back, already we had a film that we had to do, and we had to use really high-speed film, which was not necessarily available at that time. Developing was expensive. That Iconis camera was incredibly expensive, and we ran through batteries like nobody's business. You didn't have, rechargeable things like that. So we were slapping in batteries so fast that midway through, like the third of our 4 free days, we ran out. And it's not like on an island when you have no electricity or anything like that. You can't just run to the corner drugstore and pick up a bunch more batteries. We were begging them from every student that was out there, can we get, some AA batteries so we can keep the strobes going? Additionally, as kind of an afterthought, we didn't have a permit, but we really didn't need one. What we were doing is strictly a tourism kind of thing, and it was okay. So in 1980, I went down as a student. In 1981, I went back as a graduate assistant. And again, this is the kind of thing that we saw in 80 and 81. It was amazing. If I was ever concerned that, I wasn't going to see this kind of cool stuff, I needn't be. The reef was healthy. It was incredibly diverse. That included hards and soft corals. And as a paleontologist, I was primarily interested in marine invertebrates. That's what, and I jumped ahead a little bit, but when it gets time for my dissertation, that's what I worked on, is marine invertebrates, most of which live in a reefal environment. So moving a little bit forward, I finished my master's, went on to a PhD at Kent State. So yes, I'm a Midwest kid, you know, all in all through and through. And in 1984, I spent most of the year studying for my qualifying exams. And you can ask pretty much anybody that is your faculty instructors who have a PhD how much fun qualifying exams are. They're not. Okay, you spend a lot of time doing it, and then most schools use them as kind of a screen or a sieve to sort through, you know, who they think is capable of completing the PhD and not wasting their time, basically. So these are really, really tough exams. But they're also pretty good because they give you a lot of self feedback as to, okay, do I really, really want to spend all my time and my career doing this? I did, but after taking them, I needed a break. And my office mate was also doing his qualifying exams at the same time. He was a hydrologist, which means a geologist that looks for fresh water and things like that. And as we were finishing them up, we both kind of looked at each other and said, God, we got to get out of here. We need a break. So we talked to our wives. I called the people in Columbus, Ohio, where the U.S. Administrative areas were for the field station that I'd spent those 2 classes at before, and kind of sold them on a bill of goods. I said, okay, my friend and I, you know, we're both hoping to be college faculty at some point, and maybe, you know, after our experience down there, we'd like to bring school groups, you know, college groups. So would you cut us a little bit of break? We're broke, but we need some R&R. And I don't know how we did it, but they said, sure, come on down. And they slotted us in with a group, a high school group from Winston-Salem, North Carolina. Now, that only becomes really kind of important because the teacher that was down with that group was the first national winner of the Christy McCullough National Science Teacher Award. Christy McCullough is the teacher that went on the shuttle that blew up, okay? And the very next year they started an award, and the faculty that was down with us was the first winner. So needless to say, she was incredible. And so we lugged that same camera down and again took lots of pictures. Why? Because it's cool. But we did do some R&R and spent 2.5 weeks down there with the school group, and it was just incredible. And we did recuperate, ready to get back and going. So we came back that same year and started doing our regular coursework and research that we needed to do and to start our thesis areas. And lo and behold, later on that year, there was a massive mortality event. That means die-off, okay? Throughout the entire Caribbean that started actually in 82, but finally got to Andros in 94. And it is these critters right here. This is Diadema antillarium. It's the long-spined urchin. And they are absolutely, without a doubt, the biggest cow on the reef. They're grazers. They keep all of that macroalgae at bay. And they were so dense that as you flew over some of the smaller little islands in this archipelago, it looked like they had a black donut around them from the air. And that kind of density that you see was really, really common. So not only were these things, you know, great cows on the reef, but there were a lot of them. And the weird thing about this, we know that the disease, whatever it was, or malady, started around Jamaica. And then it was just simply carried by the stream, or the current, and finally, and you could pretty much set a clock. All right, it's going to hit here, and then it's going to hit here, and then it's going to hit here. And it did. And it took about 2 years to get to Andros. The weird thing is, to this day, they still don't know whether it was a virus or a bacteria. And you'd think, well, shoot, shouldn't they be able to figure that out? Once these things were infected by whatever it was, they died within hours. And it was really tough to try to find, critters that were dying that you could do some kind of laboratory analysis on. And it just never got done. And there's still arguments about what caused it. So 1985, I'm not quite done with my doctorate, but I was done enough, had the classwork done. I really wanted to get out and do what I wanted to do professionally, which was to teach. So I got a job at a small college in Illinois called Monmouth College. A couple of folks down here from Illinois even knew where it was. And went out there to start my teaching career. And the first thing I did was said, wow, I'd really like to do a field program. I think really students learn best when they're out doing things. So I'd love to do a field program. And they said, well, what do you got in mind? And I said, well, I've spent 3 times down there on an island in the Bahamas, and I think that'd be kind of cool. Do you think your students would go for it? And they said, absolutely. So if you can convince 8 students to go, we'll call it a class, and you can head that direction. Well, we had 16 on the first time, so it was obviously popular. We went down, and after me telling them all about how cool this reef was, I didn't know anything about the die-off, okay? I was not a marine biologist. I didn't care about marine stuff other than it was cool. And I was teaching, geology classes, and this being my first year of teaching them, I was just too busy to even pay any attention. So we got down there, and surprise, in a bad way, the reef was all fuzzy. And it had all this macroalgae growing all over. And so, we talked to the people that were down at the research station. What happened? And they told us about the die-off. And it was horrible, absolutely horrible. So a lot of my students started saying, well, did anybody, document this? No. So we asked the people that were at the field station, did anybody go out and document it? No. No, we didn't really know it was coming so much. So a bunch of my students said, well, that's a real shame. We wonder if the reef will ever rebound from this. And that question right there kind of set me off on something that really was going to control much of my research interest for the next couple of decades, really. And that's what I'm going to talk about. So basically, we said, how would you test whether, the reef is improving or getting even worse? Or, how would you test that and how would you document it? And they came up with some really interesting projects that students could do, okay? One of them was something as simple as counting, per square area or, on some of the isolated coral patch reefs that were kind of systems unto themselves. They would go out and count how many, different kinds of fish there were, how many different kind of invertebrates, just a simple thing. And that's kind of neat because it was the first that a lot of them ever did in kind of, real documentation and real empirical research. Counting something, taking good notes, learning how to take those notes, come back to a lab or another place outside of the field study area and synthesize them. What do they mean? Why are they important? What did we take that wasn't important? What do we not need to do in the future? What do we need to do in the future that would make this more sensible? And over the duration of about 7 years then, there was a couple of things that we noticed, okay? None of us were really proficient at this, and we didn't have a great analytical, feature. We just noticed something. And what we noticed was that there weren't any diadema, of course, but other urchins that were not affected by whatever that malady was started increasing in number, which made sense because they're also herbivores. But they don't move as fast, and there's not as many of them. Also, we saw parrotfish and a couple of the other algae-eating fish and coral nibbling fish And some of the crabs are also algae eaters. And they all started increasing in number, which makes sense, right? I mean, it was a vacant niche and something, saw opportunity there. So we started documenting that. Which fish were doing better? Which kind of urchins were doing better? And we didn't really know what the endpoint was. There wasn't an endpoint. We just wanted to see what was going on and then prove it. And that's good enough for undergraduate research. It really is. I mean, you're not expected to, come up with the next cold fusion or something like that. It's just a way of filling in gaps. So, a lot of my students came back for the second, third, and fourth time. We caught them as a freshman. They had such a great time. They took it as just a survey class to start with, and then they said, "Can we go back and actually do this for credit for research?" And we worked with the administration, and they said, "Sure." So a lot of them came back and started doing things as simple as taking underwater pictures from exactly the same spot. And they used their old pictures to determine exactly where that was. So what we had then is a temporal recording. Temporal means through time. A temporal recording in the simplest, easiest way to try to document how things were changing on the reef. And some of the reefs were changing a little bit. Some of the reefs were changing hardly at all. But we had photographic documentation of it, okay? And we also had their notes. They were all taking as good a notes as they could. That was part of the deal with research. You had to learn how to document things, okay? So not just photography. But again, the reef was horribly fuzzy. I mean, it wasn't, as clear as normal or normal as it had been before 1980. But the students were documenting things and doing kind of interesting stuff. Then, much to our chagrin, Hurricane Andrew in 1992 wiped out much of southern Florida. And included in that wipeout were a couple coastal pet stores that had saltwater aquariums with this really pretty ornate fish in it called a lionfish. Some of you may have seen them in the wild. Some of you may have even seen them in aquarium. But these were definitely invasives. And the legend is that these stores were inundated with salt water from big waves coming in with a hurricane, and these fish escaped. Maybe that's true. We don't know, really. But we do know the timing seems to be right. But also we have anecdotal evidence of people that had these lionfish in aquariums, and they started getting too big for them, so they flushed them down or released them in the ocean. Either way, there was enough of them density-wise that they found mates, and they started doing what horny lionfish do. They mated and had little baby lionfish. And that's a bad thing, okay? These are definitely invasive. And in 1994, while doing one of these little reef surveys, one of my students popped up on snorkel and said, "I just saw a lionfish." And I go, "Okay, maybe." "No, I really did." And I said, "Okay, maybe." And they took a picture of it. And they said, "Yeah, I got a picture of it." And I go, "Okay, well, at that time," you'll see in the next slide, that they were using these throwaway underwater cameras. And we had to wait until we got back to the States to get it. So when we landed as a class at the airport, we had like a 2-hour layover. The two students that claimed they saw this got a taxi, ran to a Walgreens, had these things rapidly, processed and printed so that when we got on the plane, they were showing me pictures of this lionfish. So indeed, they did see one, and it was the first sighting of all of Andros, as much as that might mean. So what about these lionfish? They're highly toxic, even to humans. You get pricked by one of those little spines. If you're kind of feeble or old, you might die. I mean, there's a lot of deaths that have been attributed to lionfish. But at the worst, or that's at the worst, at best, you're going to get sick. And the same is true with most other animals besides humans. These things are ambush predators, which means they lie quietly and almost motionless. And then when something that they look like, they want to eat, they spring like a spring. I mean, it's just like bang. And it's amazing to watch. These things are awesome hunters. But they're ambush predators. They're indiscriminate feeders, which means they'll eat anything that goes by that looks like it's food. That's bad because it means they'll eat all the fish that are out there. The weird thing too, it's not terribly weird, but you bring in a uninvited invasive. I don't know that any of them are invited. Well, yeah, we have invited invasives around here. The Asian pear, the tree that are, people that build houses and sell, lots, put everywhere because it's a beautiful flowering plant at the beginning of spring and makes everybody feel good. Well, that's definitely a problematic, plant. And now we're trying to get rid of it, and we can't because birds spread it all over the place. Well, I don't want to digress too much. But at any rate, the local reef-dwelling population, whether it be crabs or fish or whatever, they were totally unprepared for this. They didn't recognize that the lionfish was a predator and that they could be lunch. So consequently, the lionfish did really, really well. Normally it takes them, 4 years before they get to maturity so that they can breed. In the Bahamas, we were seeing it happen in 2 years, as compared to elsewhere where they were native, all right? Even the predator fish, like the barracudas and some of the others, the grouper, they had no idea how to deal with these guys. They didn't eat them. And they didn't, those that did, some of them, got that toxicity and died. So, they kind of learned from one another. It was a really, really big problem. So in 95 then, after the first sighting of these, the students said, well, we should document then what the reef is doing because of the lionfish. And I thought, hey, that's a cool idea. And we can do it by doing the same thing we've already been doing, counting fish, counting invertebrates, making, census records and things like that. So we actually in 95 started real research. And what I mean by that, some of my juniors and seniors that had been down 2 or 3 years, wrote proposals. They went out and solicited funds, even from mom and dad, or somebody to help them do their research in the Bahamas. And by this time now, we had a really big advancement in how we could do it. Instead of having to lug that big Nikonis camera around, these little throwaways became available, and they were cheap enough that you could actually afford them. But they had some problems, okay? They had a limited color filter to them. You couldn't take them really deep. And also the depth of field was so that you had to be only so many feet away from your subject. And if it was any further than that, it was just blurry as all get out. You couldn't even see what it was. It lost colors if you went down below about 15 feet. The blues were gone, or the yellows were gone, the reds were gone, and the blues stayed around, sorry. You still had the cost of developing them. And it was not cheap. It was more expensive than your regular run-of-the-mill, stuff that you take. It did take us a while until we got home, sometimes weeks before we could get back to see what we actually took. And it had preset shutter speeds, and of course then the film speed was preset. So problems was that it had any kind of time you moved it a little bit or your subject was moving, it blurred, okay? So it wasn't real precise. Even with high-speed film, it was kind of garbagey. The viewfinder in these things were also inaccurate. So what you were looking through the viewfinder was not necessarily what you were taking a picture of. That can definitely be problematic. And then some of them, especially because we transported a lot of them down together, probably, those nice, real good baggage claim guys or the baggage handlers, busted them, even with them being padded. And a lot of times that was problematic too, because to go through, we didn't have TSA then, but you still had to go through customs, and they would open everything up, and then you had to repack them, and it was a pain. So some of them leaked, and that was a bad thing, especially when you got more pressure when you went down, even on snorkel. And then, believe it or not, the worst problem was these damn things floated. Okay, so if you had more than one, which is what you'd probably want to do, you had to have a rubber band that connected to it and then to your wrist or something. And it was constantly getting in the way because it would be floating up, and you'd have 2 or 3 of these. And, we necessitated a change in our plans. So we started getting runners from the surface boat that was keeping an eye on things to the snorkelers and running things back and forth so they wouldn't get tangled up in them. It was just not ideal, okay? But it was a lot better than before. Yay! But this is an example of the kind of pictures that it would take. Not what they were cool, because if you lived in Indiana and taking pictures of colorful fish and the reef, that was neat. But I look at these pictures, now, and it's like, wow, that was really uninspiring and underwhelming. All right, well, in 1998, we decided to take some of those pictures and go around an entire patch reef area, okay? So most of these were about the size of this room. Some of them were smaller, and we went all the way around them, and then we would produce the pictures, and then literally we would try to put them together, okay, with tape. And we finally got a little bit more adroit at taking the negatives. We went over to the art department and said, okay, here's the negative. Can we kind of play with the negative to at least make sure that these things line up better? And some of the things that we produced were actually pretty cool. So we would have this long line of photos taped together, some a little bit higher, some a little bit lower, or whatever. But we at least could see what the reef looked like all the way around 360, okay? Now, to keep anybody who does any kind of photographic documentation in science knows you have to have a scale, right? So our first scale was a ruler. Very quickly we saw that was not going to be adequate. One, we couldn't even read the ruler while we were down there. So while we were down there, we took a stick, made it into a meter, and then every centimeter we colored it different, red and white. Okay, you've probably seen those laying around some places. Surveyors use them all the time. So we made one of that, and we'd stick it in the image, okay? So we have something, we knew how big some of these corals were. We could actually then, back in the lab, determine how much they had grown, or had they not, or had they died, or all that kind of stuff. And that's what the students were doing for their projects. Again, the scale was an issue. The focus distance for these preset cameras, you had to only be 5 feet, and only 5 feet. If you got 4 feet, they got distorted. If you got 6 feet, they got distorted. Well, try while you're bouncing around on snorkels, staying at that exact distance. And you're only, a few feet below the waves, and the waves are swelling. And yeah, it's a challenge, to say the least. But we did the best we could. Still had problems with the blue saturation. It wasn't great, but I love this. Invention is, the product of necessity. The scale wasn't working, and so we started talking about this when we came back the first year that we did it, in 1995 maybe. And one of my students said, what we need is a nonlinear scale. And I thought, yes, that's what we need. And they said, well, how about a ball? Okay, that's a good idea. And then they came up with, how about a bowling ball? Yeah, because you wouldn't have to worry about it being floating and buoyant. So they went out, and the first time they bought a bowling ball at a garage sale, it cost them like $0.25. It was a 16-pounder. And absolutely, but they carried it, they got it, and they painted it yellow, red, and blue with a black stripe between them. and we knew what the spectral values of those were. So when we did the developing, we could tell, that blue was supposed to be this blue. So we would use filters to bring it up to there and simply then drag the yellows and the reds up to match that. I mean, I think that's ingenious. I would have never thought of it, but my students did. So the second year, our improvement was we took an 8-pound bowling ball down instead. They're all the same size. If you've ever been bowling, you know that. Even little kids' balls are the same. They're just not the same weight. So when we got down to the field station every year, people would wonder, what the heck is this bowling ball doing down here? But that's what it was for. Okay. So in 1998, when we started doing this stuff, we said, okay, we need more. So we put out a call for everybody that had high school and college classes out of this field station called FORFAR. And we said, if you've taken underwater pictures and you have extras, and a lot of these places that developed, like Walgreens, would give you a second set for free. So we weren't even asking for things that they, had to pay for extra. So I was really shocked, but we got hundreds of these back. And because the field station took people mostly to the same sites, because they were close by, and that made sense, but also they concentrated then on certain areas. So a lot of these pictures that we were given that are all time stamped throughout the entire year augmented the stuff that we had taken, because we were going down in January and occasionally in June. But now we had stuff from all year round, and we could actually look at short-term changes in some of the coral heads, which is really cool. And again, it gave me more projects for the students. So from all that, and we also eliminated places that they usually took snorkelers for the first time there, because I'll tell you, even snorkelers who love reefs can beat the crap out of them with fins and stuff like that. So we discounted those, but we selected 8 sites. And 2 of those were shipwrecks, like this one right here, because that gave us a flat plane, the sides of it, which were making it easier and easier. And by this time, we also then had to ask for permits for the Bahamian government, and that was kind of cool. And their requirements were that we had to be completely non-invasive. So we couldn't even put pins in the coral to run transects. So that was verboten. And it also said that we had to include Bahamian high school students and high school faculty as part of our research team, which ended up being an incredibly positive thing. So in around 2000, we began a partnership with the high school that was nearest the field station, and that's called Central Andros High School. And they ended up being not only great researchers, but a wealth of knowledge from their parents and grandparents about the reef as it was in long time ago. At this time, we also had a couple of my students say they were interested in learning how to scuba. They paid for it, their family paid for it, or whatever. So we said, great, that means we can stay down. We don't have to just worry about how long you can hold your breath. And it did some good things, but it also did some bad things. It increased the depth and lengthened the downtime that they were looking at the reef, but it also added a lot of weight and bulk to carry things around and to get them. And it also increased safety needs, okay? So we had to have more training in safety and first aid and things like that. We also then realized we needed an extra body per group to help spot things and also watch the bowling ball, because when they would set it down, the currents would just roll it along the bottom, which is not a good thing because it rolls over, potential things that you're not supposed to be messing with. So we had, to think through those kind of problems or challenges. So we had runners basically, or snorkelers, that went from the divers, back and forth, carrying data planes and all kinds of, and those cameras, and it's kind of weird. And then the scribes at the surface in the boat would, jot down to make sure that we knew exactly where the camera was taking pictures from. So they used markers and stuff like that. And it was really fun, though, adding a lot of the high school kids. And surprisingly, maybe not to you, but it is to me, there's a lot of island kids that can't swim. You'd think, that would be the first thing. If you ever watch a Moana, right? Can't everybody swim like a fish? No, they can't. So one of the programs that we started that was kind of to help feed into this is to take students that were identified as interested in helping us. We had to teach them how to swim. And then we had to teach them how to snorkel. And it was interesting. All right, so 2000, so you can see what we're doing as we're going through time. Got it. The Bahamas National Trust got involved. They started saying, hey, this reef is really important. Other places internationally said the same thing. They wanted to make a national park, and they wanted to protect the reef, which is all a great thing. And, people said, wow, that means we won't be able to go to it all over the place if you make it a national park. And yet ecotourism was starting to become important to the local folks there, especially as the population were decreasing. But they asked the obvious question, who knows anything about this reef? Well, if you saw, no, we didn't have Hermione as part of our research team, but we started waving our hand basically, and we didn't have to do it much because most of the high school teachers that we worked with said, well, this guy down here who comes every year and has been coming for a long time, he knows the reef. So we got to be part of the initial setup for the reef. And this is a little interesting thing, and Mike just gave me this high sign to get going faster. I don't have that many more slides. But in the government of the Bahamas is kind of interesting. They became a country in '73. They only have two parties. It's more like a parliament. But the 2000 mark there where they get the cell phones, that allowed all of the little off islands, not Nassau or not New Providence, to talk to each other. And a lot of them said, we're not happy with the main government because they're ignoring us. Everything's going to Nassau. Kind of a common argument, right? If you live in Illinois, everything is going to Chicago, whatever. So there was a change in the leadership. And so the one leadership that was there prior to 2000, they wanted to make this national park. So they started doing all of the kinds of things you needed, like where do we want it, that kind of stuff. And they just did it in generalities. Well, all of a sudden, they called for an election, and they thought they were going to breeze through because they won so handily. And everybody that was on these off islands, family islands, said, well, it really wasn't that we wanted you out of power. We just wanted to make sure that you didn't forget about us. So they swept back into power, and overnight then, the one that had been in power said, we're going to make this a national park now. So they came and said, all right, where do we want the boundaries? And they had really no idea. They had this kind of really fat magic marker that they had marked on a map, and they said, we got to do it, but we can't have it that fat. So they took a draftsman who put a line, a very narrow line, right in the middle of it and said, that's the national park, which is really weird because it cut right through the middle of some reefs, and it was problematic, let's just say that. So here's what it ended up looking like, and that's really cool. And it does protect the big three, which is grouper, conch, and lobster. Those are all important economically. But when they made the national park, there was no budget. So consequently, there was hardly any wardens to, enforce any of the rules. So 2020 or 2002, you have underwater digital cameras available. That makes it even cheaper. We could make the photo mosaics that we were making, those long things that we were taping. Now we don't have to tape them. We can also color correct all within the algorithm, which is awesome. And in 2002, diadema started to come back naturally. There was one island just off the coast of Jamaica that was never affected, probably because the currents never went there. But now, naturally, this was reseeding with the current throughout the Caribbean. And now, these guys are all back almost to normal. So what we did is we then started documenting, like we did the lionfish eating everything. Now, we were looking at diademas return, and how the reef was getting better, which is cool. So a lot of that fuzziness went away. And also, just to put it into a time frame, this is when the real global warming debate was getting hot and heavy. Oh, and one other thing. Well, in 2008, I had 2 students come down, and like 13 other couple students came down and discovered one another and got married. And yes, that is Dr. Beachel and his wife, Ashley. And I don't know that they met there, but they certainly discovered one another there. I feel like Cupid, because there's been 14 marriages that I know about that have come from, this Love Island. And the cool thing about it is, of the 14, 13 are still married, okay? I mean, that's bucking the trend. And the only one that has divorced, she remarried a guy that was on the same trip. I don't even know how to count them. All right, so I kind of took you on a journey. When we started, who in the world could have predicted the diadema die-off? Who could have predicted lionfish coming back in? Who could have predicted these 4 major hurricanes that just beat the snot out of the reef? And then, of course, who could predict love connections, right? So what's the future of this? Well, we don't know. I mean, nobody can predict the future. But we do know that by all of the documenting that we did, both photographically and also with, field notebooks and stuff, we know where this has been. And that's a really important thing because, oddly enough, other than this little college group from St. Francis, just over the way, there was nobody else doing this. So when it came time to try to document anything, we were the only ones. And we didn't even know we were doing it. But it became important, okay? Which is kind of neat. So what was accomplished? Well, we created the only systematic photo record through time during this interval. There were a few other transects that other colleges were doing. But again, once it became a reef, they had to pull them because they couldn't put permanent things on the reef. It destroyed it, and that was protected. You can read these. I'm not going to insult your intelligence. But the bottom line is we had 47 college-level students, masters and bachelors, doing different research down there of at least a year. We had 37 publications and presentations made. It was an incredible resume builder, and we had an awesome time doing it. So how's this stuff being used? The Bahamian National Trust is using it as kind of a background for what it's doing on the reef. It's determining from some of our research and others, what areas can be open to anybody snorkeling on it, what areas have to be more protected, so only divers with permits and things like that could do it. Some places are completely restricted, and others are open for permit. So, cool. What do I think the future is going to be? It's actually guarded optimistic. Even with global warming, we now have people that have identified corals that are native, that actually can respond pretty well to warmer areas, and they're growing them artificially and then reseeding them on a reef. And, I haven't been back for about 5 years, but everybody that talks to me about how the reef is doing, they're saying that it's coming back. And that's different than every other major reef in the world. Probably because it doesn't have tourism, and probably because it doesn't have fishing, and probably because it doesn't have a lot of pollutants coming into it. So, I ended right on time, yeah?
You did.
All right.
Awesome. Let's hear it for Doc. Awesome. Thank you so much. We'll try to get the lights up here again. I'm not sure if our guy can hear us in the booth. Just be very careful coming down if we don't get these up quickly. Please, if you want, Doc will be up here to answer questions.
Yeah.
I will be up here. If somebody in the back row could just pop into the booth and ask them to turn the lights back on for me, that would be great. And thank you so much for coming to seminar. Appreciate it. Have a great day.
Thank you guys very much. You were awesome.
Would you like some water?
Best wishes. Yeah, I think by now I probably need it. Thank you, sir.
Thank you very much.